Hi, I'm Joseph. Welcome back. Today we're going to be discussing 6.4, truth tables for arguments. So this is a brief review, but in section 6.3 we discussed truth tables for propositions, and those were statements about reality. Today we're going to be looking at arguments. Truth tabling is going to be the exact same, except for this time we're going to be doing truth tables for arguments. So if we have two propositions, we're going to have 4 lines on the truth table. If we have 3 propositions, 8 lines on the truth table. If we have 4 propositions, 16 lines in the truth table. And then we'll work through it on an argument. So let's go to Hurley. All right, so Hurley says, hey, truth tables provide the standard technique for testing the validity of arguments in propositional logic. To construct a truth table for an argument, the following steps. So it gives us 4, and we'll be doing these today. First, symbolize the arguments using letters to represent the simple propositions. Well, we did a lot of that in the previous section, so that's review. 2, write out the symbolized argument, placing a single slash between the premises and a double slash between the last premise and the conclusion. 3, draw a truth table for the symbolized arguments as if it were a proposition broken into parts, outlining the columns representing the premise and conclusion. And 4, look for a line in which all the premises are true and the conclusion is false. If such a line exists, the argument is invalid. If not, it's valid. So we're testing the validity of arguments now, okay, in this section. So for example, let us test the following argument for validity. So we have our English, right? We got to break it down and symbolize, which is we're going to translate the English into symbolic logic. So let's look for trigger words. If juvenile killers are as responsible for their crimes as adults are, then execution is justifiable punishment. So we know we have an if, then. When we have an if, then, what symbol do we use? A horseshoe, right? It's conditional. And then what about number 2? Juvenile killers are not responsible for the crime. So that's a repeat of the if up here. And then therefore, execution is not a justifiable punishment. That's a repeat of the consequent up here. So if we were to symbolize that, the first line is J horseshoe E. The second line is not J, juveniles are not as responsible. And then the conclusion, therefore, execution is not a justifiable. So this E, we're going to say not E because it has not, right? So there's our symbolized argument. And what Hurley was saying above, he was saying, hey, how many premises do we have here? 2, right? 1, 2, and then conclusion. The line, so when we see an argument go down, the line equals a conclusion marker, and that's review of chapter 1. So let's say J horseshoe E, he says, look, J horseshoe E, single slash, that just means that's one premise. That's another premise. Double slash means that's the conclusion. So take the argument vertically and make it go horizontally, okay? So we go from this to this. And you can see an argument in your head either way. But in order to do a truth table, it's very practical to put it this way, horizontally, and then do the truth tables vertically. So this is a review again. We have how many propositions here? This is a review of 6.3. 2, right? We have a J and an E. J and an E, so proposition 1, proposition 2. And then J is just a repeat of this. And then, so we'll take the first proposition and we go true, true, false, false. Now, when we have 2 propositions, how many lines in the truth table? 4, right? True, true, false, false. The second one, true, false, just like we did in 6.3. And then we repeat here for our J and our E. Then we go down, and then we do the tilde. We negate whatever we have. Do tilde, negate whatever we have. We solve for the horseshoe. So true, true is true. True and false is false. False. So what we're doing now is once we do the truth table for our argument, we take the main operator for each proposition. So right here, right here, right here. And we'll do a box around them. And this is just 2 premises and conclusion. If it was 30 premises and a conclusion, 30, boxes. But this one only happens to be 2 premises. So we have 2 rectangular boxes, and then a conclusion box. So he's saying look for when it's true and false, meaning if we have two true premises and a false conclusion? Well, we have that here, two true premises and a false conclusion. He says, if you have that in your argument, it's invalid. Because remember, validity is hypothetical, and that goes back to chapter 1 review. If you have the premises, if the premises are true, would the conclusion follow? And if the conclusion would follow necessarily, we said that it's valid, right? Well, here we go. The premises are true, and the conclusion should follow necessarily, but it doesn't. It's false. Therefore, the whole thing's invalid. So you got a review of chapter 1 here, and you got a review of the beginning sections of chapter 3. So notice this is true premise, false premise, false conclusion. We wouldn't expect the conclusion to be true because we have a false premise. False premise, whole thing's true. What? Again, go back to chapter 1. It turns out you could have two true premises and have a false conclusion, or you can have two false premises and a true conclusion because they might not relate to each other. You could have true premises or false premises all day long. Do they connect? Do they support the conclusion? That's what we're after here. And the truth tables allow us to look at all possible truth values for these premises. All possible truth values. There's no other possible truth values because we only got two propositions and we've plugged in all our truth values. So if we were to have seen, if this would have said true, true, and true, then you would say this argument's valid because there's no line in which the premises are both true and the conclusion's true. So like a line 1, line 2, line 3, line 4. So this one's invalid. Here's another one. And you can read this and look at the English, but we know we have an if, then. The second one's if, then. The third one's if, then. Go back to chapter 1. This is a specific form of a deductive argument. It's called hypothetical syllogisms. If you have two premises that are if-thens and the conclusion's an if-then, hypothetical syllogism. That just means the form of it should tell us that if we have two true premises, the conclusion should be true. And here we go. We have, notice this one, he skips putting it like this. He just goes straight to the horizontal. So he says, hey, I'm going to use my O and my T and my B to symbolize what's going on in here. The B is the business in general. The O is the if insider trading occurs, and the T is investors will. Insider trading occurs. And then up here, it says if insider trading does not occur, and that's not T. So he symbolizes it right. He has 3 propositions, so it's 8 lines in the truth table. And review from 6.3, we know that the first one's 4 trues, 4 falses. For our O, we go straight to our T, our second. True, true, false, false, true, true, false, false. And then we go to the B, true, false, true, false, true, false, false. Then we just plug in the rest, right? Then we solve for the tildes. And then we look at the main operator in the first premise. It's a horseshoe, right? So we solve for that one. How do we do that? We look at this one and this one all the way down. Got the tilde. Then we do the horseshoe here. Since this is the main operator for the first premise, we box it. Main operator for the second premise, box it. Main operator for the conclusion, box it. Now, line 1 through 8, go across. Do we have a true, true, and a false? We have a true, true, and a true. True, 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 and a true. True, true, and a true. True, true, and a true. True, true. We don't have a line where it's 2 true premises and false conclusion. Therefore, the whole thing is valid. That's what Hurley's saying right there. The whole thing's valid. We don't care if it's got false premises and true conclusion. What we're looking for is, does it have whatever number of premises it has? We're looking for a line in where they're both true and the conclusion's false. That will let us know it's invalid. If we don't see that, the whole thing's valid. Again, this whole section is a way of testing whether an argument's valid, right? Take the English, it's conveying meaning somehow, right? This thing right here, right? And let's just say you didn't know anything about insider trading or business and securities and markets. You're like, I don't know what is going on here. No problem. If you can symbolize that argument, and provide truth tables for it, you can tell whether this whole thing's valid or invalid without even understanding anything about the English. Isn't that brilliant? And that's where this mathematical abstract thinking comes in. We can put it into a certain simplified structure, give all possible truth tables, or also all possible truth values, and calculate whether it's valid or invalid. And that's separate, by the way, of whether it's sound. Remember, this is a review of chapter 1. You could have a valid argument and the whole thing could be unsound. And if it's unsound, that just means one of the premises is false. But in this section, we're not looking at whether it's sound or unsound. We're looking at whether it's valid or invalid using truth tables. So let's go down. You can read about Ada Byron if you want, and the Countess, or the Countess of Loveless. I mean, whatever's going on there, romance story. So here's a review Hurley gives us. Look for a line that has all true premises and a false conclusion. If you find such a line, the argument's invalid. If not, the argument's invalid. Okay? So he talks about tautologous conclusion here, and it looks absurd, right? Two premises and a conclusion. The sky is blue. The sky is not blue. Therefore, Paris is the capital of France. What? Like, it could be that this is valid, but does it sound like, do they have anything to do with Paris being the capital of France? So anyways, he takes these premises, he says, let me slap this bad boy into a symbolized argument. Boom. Premise 1, S, the sky is blue. Not S, the sky is not blue. Therefore, Paris is the capital, And he solves, and again, if there's a proposition, you just plug in your truth values. And then there's a proposition with a negation, tilde, and whatever. So do we find a true, and a false? No. Therefore, the whole thing's valid, right? But this is the cool part. Even if it's valid, it doesn't mean that it's sound. I'll read this. Since the premise of the argument is inconsistent, there is no line in which the premises are both true. Accordingly, there's no line in which the premises are both true and the conclusion's false. So the argument's valid. So it's valid, right? Of course, the argument's unsound because it has a false premise. Where's the false premise? Here, 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 here. So this is an example of an unsound but valid argument. And what does this mean? Validity just means that the argument has the right sort of structure. The structure, if it's valid, means if you plug in the English the right way, then the conclusion's forced on you perfectly if the English is in the right way. So the English is in the right way, meaning the premises are both true. Okay? So validity deals with structure. How's the argument built? And soundness deals with the structure and one more thing. Are both premises true? Turns out this one's false. Okay, so, and then you can read this about Bern being the capital of Switzerland. Bern's the capital of Switzerland. Therefore, it's either raining or not raining. I mean, what? So he just says, look, this argument's a tautology. Accordingly, there's no line in which the premise is true and the conclusion's false, so then the argument's valid. So he says this is valid, right? But it's not terribly convincing. Like, hey, we get that this is the capital of Switzerland, but what's that got to do with it raining or not raining? But it's supposed to be forced on us. If we grant this is true, this is going to be true. But he says, incidentally, it's also sound because the premises are true. So when we have a true premises, the conclusion's true. What's he say? Let me see. Accordingly, there's no line in which premise is true and the conclusion's false. Oh, that's right. That's right. Let me look here. Yeah, anyways, you can, this is one of these, just for me to simplify this for you, these two arguments, they might be valid, but nobody talks like this. And he's just showing you, look, the structure's right. and I'll leave it at that. Let's go to our homework examples. So I've taken sections 1, which you have to, look at the English, translate, symbolize, do your truth table, tell me if it's valid or not. 2, you don't have to translate. It's given to us. You just take the vertical, make it into the horizontal, do your truth tables. And then 3, Android writes. It just gives you a paragraph of people talking. It's crazy. They're talking about rights that androids have. What? Yep. So what you have to do is see if you can find arguments in here. And there's multiple arguments going through this. I'm going to give you an example of two. And the reason we do this is the practical import. It's like, hey, if somebody's thinking logically and talking logically, we'll be able to detect it with certain trigger words like if, then, and, however, but, therefore, things like that. And maybe we can construct an argument, tell whether it's valid or not. So with that being said, we will go. Let's do this. Get out of here. Okay. Sorry, give me a second. Let me open up my laptop. I have it in record mode. But what I want to do is I just labeled it wrong. Okay, so it was the right one. Okay, so let's go back into my. Okay, thank you for being patient there. So I've taken Hurley's text and I've just put it in here. Okay, so let's look at number one. If national elections deteriorate into a second here. If national elections deteriorate in a TV popularity contest, then smooth-talking morons will get elected. Therefore, if national elections do not deteriorate, then smooth-talking morons will not get elected. So let's do this. And he makes it pretty simple. He says, hey, I'm only going to give you, the two letters that you can use. So we know right now it's two propositions with how many lines on truth table? 4, correct? So we'll just say, we'll go straight to our translation. Let me go to the pin. Okay, so let's just say if national elections deteriorate, we'll use N there for S, and then we'll say if national elections deteriorate, then therefore, if national elections do not deteriorate, so we have a therefore. National elections do not deteriorate, so not in. Then smooth talking will not go on. So like that. So we know we have two propositions, 4 lines on truth table. So I'm just going to go in and start plugging away. Again, this is review for section 6.3. Let me do this. Let me go and make it better. Yeah. And so N is true, true, false, false. And let's look here. Sorry. Okay, so let's negate these guys, meaning we're just taking the opposite of whatever it gives us. And then we know we have the main operator. So let's do this horseshoe over here to the left-hand side. True and a false, so that's false. Everything else is true. And then keeping in line with what Hurley says, that's our premise. So we're going to box them out, right? And then now we're going to look for, we have a true and we have a false. So we know the whole thing's false. All the rest is true. So like this. Simple reminder, that's the premise, this is the conclusion. So now we're going to look for line 1, 2, 3, 4. We're going to go across. Do we have a premise that's true with a false conclusion? No. Do we have a premise that's true with a false conclusion? No. Do we have a true premise with a false conclusion? Yes. Bingo. So he wins the prize of being, and this is how we can say this, invalid at line 3. They don't have to say invalid at line 3, but it's invalid, right? The whole argument's invalid because we have one instance of where we have a true premise and a false conclusion. Right there, all you have to have is one. You could literally have 50 million lines of argument. The second you get a instance where in this argument the premise is true and the conclusion is false, you stop right there. The whole thing's invalid. You don't have to go any further. So we just say it's invalid at line 3. And let's say now line 4, we can look. It says, true premise, true conclusion. Even if it was false, we could say invalid at line 3 and invalid at line 4, but we don't have to. All we have to do is prove invalidity once and we're done, okay? So in that sense, that should be pretty easy. So let's continue on. Okay. I think the next one's 4. Let's do. Okay, so 4. If they're, and by the way, these are starred in the back of the Hurley text or in the mind tab, so the answers are already given to you, but I'm showing you how to do them, okay? So that you can walk through it with me. So right now, you could push pause, do it yourself, unpause, and then say, did I do it right? Like, because the truth tables, remember in this last video, I told you, the only way you'll get good at these is doing them by yourselves. Okay, so if there are dried up riverbeds on Mars, then water once flowed on the Martian surface. There are dried up riverbeds on Mars, therefore, water once flowed on the Martian surface. Hey, this might be important, man, because there's people trying to land on Mars as we speak. I mean, we got like, what's his name? Oh my gosh, the dude from Tesla, Elon Musk, right? And Gates and all these other people trying to go to Mars. Hey, man, this might be important for them. Let's see if this bad boy is valid. All right. So he says, we have D and a W. We should be able to plug in. And I'm just going to do that. So we have if there are dried up riverbeds on Mars, then water once flowed. So we have a D horseshoe W. That is just, I'm sorry, that is, ladies and gentlemen, that is sloppy. Let me do it again. And then the second premise is D, right? There are dried up riverbeds on Mars. And then we have a conclusion, which is marked off by a double liner, right? So we just have a W. Now, if you wanted to look this up, this is review. This is, so from chapter 1, you could look at it this way, vertically. So if D, then W. We have D, therefore we have W. This is what? A modus ponens. And in my previous lectures, I said, hey, whenever you come across a modus ponens, it is always valid, 100% guaranteed bulletproof validity. And then I said, but if you want to see why that's the case, we'll discover it more in chapter 6. Well, here we are. Now we're going to discover why this is valid, but that's a modus ponens. Why? Because we have the a conditional right here. We have the antecedent being true, and then we have the consequent being true. So it's an argument. All right, so how many propositions? 2. How many lines in the truth table? 4. Let's start plugging away. True, true, false, false, true, false, true, false. We just plug these in from whatever we had, and then these as well. Okay. Line 1, 2, 3, 4. So now we solve for this first conditional. Why? Because it's the main operator. So we'll just say, look, there's a, how do I I need to figure this out on my tablet, how to take away what I just did. Me no. Okay, so we'll just say, look, that's one. That's the second one. That's the third one. Meaning I'm going to draw my rectangular answer right there with my truth value. So let's plug it away. So true and false. So I know that's false. I know the rest is true. That's my little shortcut. Go back to 6.3 to figure out what I'm talking about. 6.2. Or actually 6.2. And then we were using them in 6.3. So D. So I know this is boxed out. That's boxed out. And so is this. And, if you wanted to, you could put a double box right there to be consistent with the double line. However you want to do this at home, and plus, if you're using graph paper, you're already a step ahead because you're not as sloppy as me right now. So we're going to look at line 1. Do we have a true premise, false conclusion? No. True premise? No. True premise? No. We're looking for both premises that are true and a false conclusion. We don't see it. We do, however, see a true, and a true. So we know it's valid. And it's not invalid because there's no line, 1 through 4, there's no line in which both premises are true and the conclusion's false. We don't find it, so the whole thing's valid. Done, right? Wasn't so hard. Let's go to 7. Everybody with me? All right. And like I said, you do these by repetition, it actually becomes a little fun, like you're solving a puzzle. So you start plugging away. It's like easier than a Rubik's Cube, by the way. You solve those kind of puzzles. By the way, when I was a kid, I used to solve not the Rubik's Cube, but the pyramid. Anybody got those? If you haven't seen that, it's a Rubik's pyramid. I could solve those like real easily. I have no idea how. I just figured out patterns and I just did it. I think that's how people stumble onto the Rubik's Cube. If they don't look at a YouTube video and if you see patterns over and over and over, you kind of just, in your mind intuitively does it. Like subconsciously, you just start solving it, which is mind-boggling. We're not doing that here. Our mind is not intuitively saying, hey, here's a truth table. Are you kidding me? You have to write this stuff down. All right. So I'm on a tangent to nowhere. Let's come back. So 7, Einstein won a Nobel Prize for blah, 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 blah. We know that we have 2 propositions. We have to symbolize this bad boy. So let's see. Let's look for some trigger words. We have an either or. Aha. Oh, give me a second. Either or. But he did win, therefore he... Okay, so on this one, it looks like we have what could be disjunctive syllogism from chapter 1, but we have to find out, is that the case? It looks like we have one option, we have a second option, and then we negate the first option, and then we have the second one, whatever that is, A, B, C's, 1, 2, 3, it doesn't matter. You have 2 choices, you negate one, you have the other, right? That was a disjunctive syllogism. That's the kind of structure. It could be the case that is, but we don't know yet. So we have to plug it away, right? Or translate this argument by putting in its proper symbols. So let's try this. Let's P or S. We have 2 choices. And the first one said, but he did win the Nobel Prize. Okay. And by the way, when it says photoelectric effect, this is my language. I'm an X-ray tech and a nuclear medicine tech. This whole world is how we shoot X-rays into you and use nuclear medicine. It's pretty awesome stuff. Anyways, okay. And then we have our conclusion, which is not S. So if we were to look over here, and take our choices and look at it vertically, we would know that this is invalid without even doing the truth table. This is fascinating. Why? Because in chapter 1, remember how I told you have choices 1 and 2? You have to negate one of them. Are we negating one of them in premise 2? No, there's no negation. So the whole thing's invalid. But we have to prove it. I know. I mean, we just did, right? But we have to prove it in our homework for 6.4. So let's prove it. All right. 2 propositions. true, true, false, false, true, false, true, false, true, true, false, false, S. Oh, yeah. True, false. We're going to solve for this. So disjunction's true when at least one side's true. And again, what are our main operators for the premises and conclusion? There's a main operator. There's one. It's not an operator, but it's the truth value. So, and then there's the operator, the tilde. So that's what we're going to eventually be looking at when we highlight. I could use that yellow thingy, or I could, for example, you could get fancy and be like, hey, I'm going to make my premises green. Oh my gosh, I'm using my mouse. Wow, this is absurd. Okay, no more mouse when I'm using colors. I could use my premises green and I'll make my conclusion blue. You could do that. You don't have to use color coding, but our mind works in certain ways and the colors stand out to us. So I'm just showing you different ways of how you could do this at home. Like you could use a marker down below or on top to show, your main truth value of the premise right here. So let's go back to the basics. Line 1, 2, 3, 4. We're going to go across. Do we have a true, true, and a false? No. True, true, and a false? No. Oh, yeah. Right here. True, true, and a false. We have two true premises and a false conclusion. And we know that when that's the case, it is invalid. And if I want to get fancy-pantsy, invalid at line 2. So that's proving, like we did up here, just looking at the structure, if you reviewed from chapter 1, you see like, hey, this is invalid because there's got to be a negation in the second premise. It's got to negate one of those choices to get this to come down. But it's not doing that. In fact, this thing shouldn't even be negative. So a true just disjunctive syllogism would look like this. P or S, let's say not P, therefore S. It wouldn't be not S. You would negate one and bring down the other one. So anyways, invalid. Let's move on. Let's go to 10. All right, so we got three propositions, 8 lines in the truth table. Oh, 8 lines, right? So I'm going to speed up on this one a little bit more. You can pause this if you want. Because again, the best way to learn this is for you to struggle through these premises and conclusion, because you got to do step 1. You got to translate the English using symbolic logic. You got to use your propositions he gives you, these 3. Then you got to figure out, okay, like what symbols am I going to use? Let me give you a hint. If, then. Ooh, we have a but. Ooh, what's that but doing right there? And notice this semicolon over there. It's standing out. It's separating one premise from another or one sentence from another. Just be thinking that. Then we have a then. Oh, we have an either or. We have a not. We have a therefore, either or. So we know we got an if. We got an if then. We know we're going to have this. We know we got an either or. We know we got another either or. We got a tilde or 2 in there. I know I saw 1. Yeah, we got 2 in there. So we know these are our symbols, right? Now, if you wanted to, push pause, try to work this out, come back, see if you're right. And then I'm just going to continue on, and I'm going to map this out for you. Oh, let me see how much room I have. I think I have room. Yes. So let me go up. Yeah, let me just do that. Okay, so RQ. Okay, so R horseshoe Q, conjunction, and there you go. And then not R, horseshoe P, and then R, wedge, not R, and then conclusion Q or P. So let's go through. It's an 8-line truth table. So I'm just going to start plugging away like I did yesterday. Again, review from 6.3. If we have 3 lines on the 3 propositions, we have 8 lines in a truth table. So first one is 4 truths. How many falses? You got it, 4. Second one, true, true, false, false, true, true, false, false. So we have an RQ. Now we got to go to the P. And right now, if you're doing this at home and you have graph paper, awesome for you. R. Maybe I can get, in the future, maybe I can plug graph paper into this Word document. Why didn't I think about it? Anyways, or even like an Excel spreadsheet or something. And then I could have my truth tables line up better. Anyways, R. Let's do, so true, 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 false, false. So R again. Got a lot of R's going on. And what am I doing? I'm simply just taking that first R over here all the way to the left. And I'm plugging in my values for R to all my R's, Q's to all the Q's, P's to all the P's. It's a lot of work. You got to do that first. So as long as you plug in your truth values correctly, solving this is least hard. This is the hardest part actually, because you can't make a mistake. Like, for example, and I'm glad I did this. See this one right here? Make it really stand out. So yeah, they look all pretty good. Let's do this. True, true. Yep. I was just counting in my head on the other one to make sure I got that first one right. Okay, good. See, that guy's a little crooked and making him stand up. Yeah. Q, and we know the Q's are... Okay, P. All right. So we got them all, and then we just go back to the basics. We say, hey, line 1, 2, 3, 4, 5, 6, 7, 8. And what we want to know, so anyways, there's our English. We looked at our symbols that we're going to use. We did see a horseshoe. We just saw a couple wedges in there. Yeah, we saw a couple horseshoes, a couple tildes. So we got them all plugged in. Got all of our truth values. Now let's solve. Okay, so let's say I do my cheat sheet here, or my quick method. I look for how the conditional could be false. Oops. And then once I find out that, I know that everything else is true. Okay, so, and keep in mind, yeah, I think I have enough room to do that. No. I know how to get around that. Let's do, okay. We'll say that's, that's right. What I'm trying to do is, in this first premise, we have one premise, 2 premises, conclusion, right? What's the main operator here? That's what I'm trying to show. That's what I was trying to put right there. The main operator is here. Why? We know it's that guy. What's the main operator in the second premise? Him. So we're going to be comparing this huge rectangle, this huge rectangle, and then this huge rectangle. So sometimes if you find a main operator and you kind of highlight where your main values of these premises will be, it'll help you, because there's a lot going on here and your mind's got to work step 1, step 2, step 3. So Anyways, at home, you might do this differently. Okay, so now I'm going to plug away. True, false, so that's false. All the rest are true. And I know that from 6.2. You can look back. Okay, this one I have to just negate. And then I have to solve for the wedge. At least one side has to be true, and all the way down they're all true, because there's no instance on these disjunctions where both sides are false, so they're just all true. And I knew that just by scanning both sides. And then so we got that down. Oh, sorry, I jumped ahead. I didn't solve for this bad boy. Ooh, yes, I'm glad I made another mistake. So which is easy to do. Instead of solving for the horseshoe, I first had to solve for this tilde. And some of you that saw that, amen to you. You know what I'm saying? You're like, hey, you messed up. But I double check these things over and over. So I had to do this first, then I solve. Okay, so let's do true, false right here. True, false right there. Everything else is true. So now I got to take the value that I got from here, compare it to here, and then I will get this one right here. So, and this is a conjunction. Both have to be true for the whole thing to be true. So I'm just going to scan and false, true. So that's false, false, true. Well, true, true. That's true. True, false. That's false. True, true. That's true. True, false. That's false. Finally, we know the truth value, the main operator, our truth value is this one. This is the one that's going to stand out. It's going to be important for our first premise. For our second premise, this will be the one. So let's go and do that. And then we're going to plug in our truth values in this and match them up. So let's say both sides have to be, so at least one side has to be true. Okay. All right, now we go across. Line 1. Do we have two true premises and a false conclusion? No. Do we have two true premises and a false conclusion? No. Do we have two true premises and a false conclusion? No. So anytime you see a false premise, you don't have to go through. So if it's false, okay, line 5, two true premises, yes. False conclusion, no. False premise, don't have to look at it. Two true premises, false conclusion, no. False premise, don't have to look at it. So, okay, the only time I have two true premises is in line 1, 2, 3, 5, and 7. And each time I end up having a true conclusion. Therefore, I don't see two true premises and a false conclusion. So therefore, we have a winner. The whole thing's valid. Yay! Like you did all that work and you're like, yes, I got it. So those of you that got this, awesome. If you didn't, you can see where your mistakes are, right? So look, I made a mistake right in front of you and I went back and corrected it. And so you can too. Or you can look at this whole thing and now compare your truth values. Did you do a tilde out of order? You know, did you figure out something was a main operator when it wasn't inside of a premise? You know, again, when you practice, you'll get better at these. So there you go. You survived. Give yourself a pat on the back for number 10. Oh, great. We're out of section 1 now. So we're done translating, at least for that part of the homework. And now we're just, Hurley makes it easy for us. He says, hey, here it is. Bling. Yay. You don't have to do any translation. It's already done for you. So what you do now, and I'll speed along, you simply put this bad boy horizontally. Sorry. I said horizontally. Can you seriously, really? I did get up I did get up and surf this morning. I got up at like 5, went surfing, so a wee bit tired. So your brain can do that. All right. So we have how many propositions? 1, 2 lines in the truth table, right? I mean, this is as easy as it gets. True, false, true, false, true, false, all the way down. Let's negate this. And that's a tilde, so let's go like that. And let's solve for these guys. And by the way, what's the main operator for this premise? It's right there. What's it for that? Right there. So I have a true and a false, so that's false. I know that's true. So I'll just say, hey, that's my main line in premise 1. So my main line in premise 2. Do I have an instance where I have a true premise and a false conclusion? No. This one I can rule out right away because it's just false. I don't have to worry. So I have a true premise, yeah, and I'm coming over, and it's true. It's not false, therefore, we have another winner. It's valid. Okay, that was easy. Let's go to 4. And like I said, the ones that I'm doing, they're starred in the back of the book, the Hurley text that we're using, 13th edition or MindTap. They're given to you. I just want to work these out with you. And you working them out with me at home, hopefully you're not doing this in your car. You cannot do it in your car. Do not do it in your car. It takes mental power that is impossible inside the car. You can't possibly do this in your head unless you're a genius. All right, let's go. Let's do this. How many premises do we have? 1, 2, and then your conclusion. So we have two premises, 1 conclusion, and we just say, hey, let's get to it. That right there, that single line divides a premise. Everybody with me? And boom, that divides the premise too. And then we know that the double line means a conclusion follows. So, and if we quickly look at this, what's the main operator for this first premise? We know it's this tilde. It's the last thing we're going to do because we do what's in the parentheses first. We know the main operator for this second premise is what? I did not hit that screen. I got close to it and it smacked right on there. Dude, come on. Oh, there you go. We know it is this, and we know for the conclusion it is simply that. So let's go here. And okay, so I'm going to start plugging away. How many propositions do I have? I have 2, so I know 4 lines in the truth table. And I make my values consistent. G. Okay, so I got to do this first, and both sides have to be true. All the rest is false. And then once I solve that, I'm going to take the opposite because I'm negating it. And I'm going to say this first line. Oh, that's... No, okay, that's fine. There we go. All right, and let me go back and do the second premise. So take the opposite of my tilde, right? Because it tilde negates whatever you have. Then I solve. At least one side has to be true. So it turns out that's the only one that's false. And I know. How many of you got that far? Proud of you. Now, the conclusion is ridiculously easy. We just negate, and then we're done. And so we're going to go to So we're looking for two true premises and a false conclusion. The only line where we have two true premises is here, line 3 and 4. And if we go across, we find out they're both true. So if that's the case, is this a winner? Yes. Proud of you for seeing that. All right. Okay. That's it. It's by repetition, you become like a robot doing these. You're like 2 propositions, 4 lines, let's plug away, and then let's, go through each line. All right. So let's go to 7. This is a 2 proposition. So yeah, we have a WX. Yep, that's all we have. So we'll just quickly do this. And if these videos help, you can let me know in the comments. Okay, so here we go. Let's start plugging away. Oh man, I went too quick. And it got so sloppy that I had to redo it. Because you don't want to put in the wrong values. You'll regret it when you try to solve and you're like, what happened? And you look back and like 1 tilde was done the wrong way, or like 1 truth value. You don't want to get caught. So X, and then my W's. Alrighty. Oh. All right, so let's do net opposite. Let's solve for this. Both sides have to be true. I'm going to now take this tilde. I'm going to say first premise is done, because that's the main operator over the first premise. And we'll go to the second premise. And both sides have to be true. And I'll take the opposite similarly like I did over there. So true, true, false. And make sure. Yep. And then last one, this looks pretty easy. This is just a wedger. Both sides are false. So at least one side has to be true, and we know that's the case there. So we'll go here. And again, line 1, 2, 3, 4. Let's find 2 true premises. We did it in line 1. So with 2 true premises, true conclusion, that works. 2 true premises, false conclusion. Boom. There he is. And ladies and gentlemen, what is this? Invalid. Why? Because we found one line in which we have 2 true premises and a false conclusion. Whole thing's invalid. And that means no matter what English you're using or what language or what meaning you plug into this argument, it will not work. And that simply means that premises, even if they were true, do not support the conclusion. Okay? So again, this whole section, we're looking at the structure. We're literally looking at the structure. Chapter 2 is looking all about the meaning, linguistics, language, what we're using to make an argument as far as how we communicate. And this is the structure in which we're communicating. That's what we're analyzing. Ooh. There. Okay. Whew. Got a little scary. Got a little scary for a second there. I thought I was deleting something. Okay. All right. So we are done with 7. Now we're on to 10, and we have enough room. Let me just see how much we have left. Okay. So let's do 10. And we have JKL. So we know we have 8-line truth table. And for some of you that feel like you have a handle on this, you can simply stop the video and work on your homework, because you already, after doing this so many times, you're like, I am gonna go out of my mind. I've seen enough of this. Or you say, no, I like doing this. I'm learning, and stay with me. But let's just say, so first premise is false. So 4 truths, 4 falses. Okay, there we go. Now I'm going to make them consistent. My K is 2. And then my J was the first one, so I know it's 4. And then my L, that's right. And then J was, the first one. And once again, you can see how graph paper would help in this situation for you. For me, I've been doing this for years, so I'm getting better at aligning these up. Okay. Let's do this. And L. So, all right. And now I solve. So I'm going to do what's in the parentheses first for premise 1. I always go for the true premise, or true antecedent, false consequent, and I know that all the rest are true once I've eliminated those false ones. And then I'm going to go over here and do the same thing, true, false. So let me make sure I got this bad boy right. Okay, give me a sec. True, false. Yes, okay, so that's good. So all right, let's do this one. Very similar. Similar structure as far as the premise, just different letters. All right, so let's do what's inside the parentheses first. We got to do, my method is just look for when it's false. Oops. Oh, yeah. Whew. I better, oh, yeah. And then all the rest are true. Yeah, if you make a mistake and it doesn't look exactly like your TRF, take that time and make it look like a TRF. Okay, so true. So I know this is false. True, false. All the rest are true. And I know that's my. And then we'll do the same for this one over here. Do the parentheses first. And this one is a wedge. Yeah, okay. So at least one side has to be true. So these are both. Oh, oops. And then all the rest are true. Okay. And then we do this guy. So true, false. I know this is false. True, false. True, false. All the rest are true. That's just the way the conditionals work. And then I know that I have... Okay, so now I'm going to look at my lines. Oh. Do I have to put those? No. Just out of repetition, I'm used to doing this. So line 1, we're looking for 2 true premises and a false conclusion. Can anybody find it? Line 6, true, true, and false is the winner. So we know this whole thing is invalid. It fails at line 6. And does it work at other lines? Yeah. So like if we looked at line 1, true, 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 all the way across. So like we were to do this, right? We know it's true. We know this is true, right? And this one, is that a true? Man, I can't tell. Maybe it failed at line 4 as well. I can't tell if that's a true or false. But either way, all we have to have is one instance and we know it fails. I think that's a false. I think that's a false. Yeah, so this is the only line it fails on 6. Because on line 7, if you go across, that works. And even line 8, that works. And I think that was a false, but when a pen came across it, and I can tell, so false, false. Oh. I think, let me just look. Okay, so that's a false. And that's a false. So that whole thing would be true. No, that was true. So let me get out of this madness right here. Oh, eliminated all that work. So we can simply go back and say, so false, false. That's a true. So it turns out true, true, and a false fails there. So 2 times in which it fails. So 10, invalid, and 8-step truth tables, they can take a lot out of you. But now, ladies and gentlemen, and I know this is a lot, if you want to see a 16-step truth table, you can follow along. If not, you're done. I only do this because, you know what, and it's funny, I won't even do the whole thing. I'll just show you how to do it, though. I'll start it for you. Because some of you in your homework, you might have a 16-step truth table, whether you're using the book or MindTap, or if you're following along and you at your home and you're not even in my class. Either way, it's pretty simple. So we'll do this. And let me make sure to, yeah. A lot going on there, right? So we can count on our propositions 1, 2, 3, 4, or to make it easier, because there are 4 different propositions. That means 16 lines in the truth table. So, and even on my tablet, I'm not even sure I have enough room to make 16 lines. And if I had graph paper, I could actually do it. And if you're following along on MindTap, I actually think it has sections where you can click a button and do all your values pretty easily. So that's pretty awesome. If not, and you're at home and you're using graph paper, it's easier for you. When you're not using graph paper like me, and you start doing a 16-liner, things, let's just say, can start swaying to the left or the right like you're a sailboat at sea in the winds. All right, so let's do this. All I want to show you is how do you do the first 4 propositions? Because we're used to doing 3 propositions, 8-liners, right? Where the first proposition is 4 truths, 4 falses. On this one, the first proposition is I'm not telling you. Did you guess it? Yep. 8 trues, 8 falses. So 1, 2, 3. Oh my gosh, look at that. I ran out of room. That's how long this bad boy is. I can do it. I can wing it. Oh. Got it. 8. So 8 trues, 8 falses. And then the second one, the E, would be 4 trues, 4 falses, 4 trues, 4 falses. Okay. And then what do we do for the third one? Yep. True, true, false, false. True, true, false, false. True, true, false, false. True, true, false, false. Got it? And then what do we do for the last one? Yep. True, false, true, false, true, false, all the way down. Okay, so that's how you would start your 16-line truth table. 8 truths, 8 falses, 4 truths, 4 falses, 4 truths, 4 falses, and then, true, true, false, false, true, true, false, false, all the way down, and then true, false, true, false, true, false, true, false, true, false, true. So then you would simply plug them all in and then solve. And it's fun. The hardest part is putting the truths and falses. As you can see me doing on a tablet, you're like, wow. But the easy part's solving. You just take your time, go line by line, figure out, and just a test, what's the main operator here in each premise. And by the way, how many premises are there? 1, 2, 3, 4. 4 premise and 1 conclusion. So we know this one's the main operator there. That one's the main operator. That one's the main operator there. What about this last one? That one. And then this one. So once you find out your operators, you solve, you get to this point where you have your values in there, like I've done all the rest of these, right? And then you go along and you say, hey, just like you would, 1, 2, 3, 4. You got your 16 lines, and you just go one by one. Do I have all truths and a false? Do I have all truths and a false? Do I have all true? And it turns out that this one is invalid. So somewhere along the line, if you were to do this at home, one of these premises, you can go all the way across the truths, and it turns out, like, I don't know what line it is because I'm not working this out in front of you, but in one instance, you will have a true, a true, a true, true, and a false. And it just means the whole thing's invalid. So if you did this and you push pause and you wanted to see if you had it right, that's the answer. I don't know what line it fails at, but it definitely fails at one line, at least one line. Okay. So the 16 liner is done, but not completely by me, but it's, as far as the answer, you got it. And so again, the hardest part is the truth values, because you've got 4 now. And so 8 trues, 8 falses for the first one. And then it's kind of a repeat for the last 3. So let's go now to Android writes, and this will be easy. This is just, again, casual conversation, but is there an argument going on in these? Yes. So it turns out it's about Android writes, and I'll read along with you. And Hurley's just taking it to the most practical level there is, and he's saying, look, modern English, are there arguments in what people are saying? And if there are, why don't you map them out and tell me whether they work or not? And on this one, I'm not going to do truth tables. I'm just going to simply translate. And at this point, you can push pause, but I'll first, let me read with you, and then I'll kind of, I'll tell you why. So I just came from Professor Shaw's class in philosophy of human nature. Dick says to his friend Erin, as he meets her in the hallway, we've discussed the question of whether an android could be a person and whether they have rights. Now, are there any trigger words for logical operators here? No. And we're looking for those, right? Because we're looking to see if we got an argument. So, well, keep on reading. Sounds like an interesting class, Aaron replies, but an android could never be a person. Seems like that could be something like a negation, but we don't know. So we'll just keep on going. And then down here, it's really quite simple, she says. If an android is a person, then it's rational. Oh, we got an if-then, ladies and gentlemen. So we got trigger words. We got an if-then, and then it looks like, so if we have that, sorry. Sorry about that. If we have an if-then, it looks like we have a conditional, and if that's the case and we follow along, let's see if we can map this out. If an android's a person, let's just say P, then it's rational, right? Look at the, but no android is rational. Not R. So it's not a person. Could we use therefore, thus, as a consequent? Yeah, but this is the trigger word so. You can go back and look at chapter 1, and that trigger word says it's a conclusion indicating word, not a person, right? So we could simply do this vertically. We know from chapter 1 that that's what? Anybody recognize that form from chapter 1? If P then R, not R, therefore not P. Modus tollens. This is my favorite argument form ever. I literally use this in my papers, most of my graduate level papers and my dissertation. I use modus tollens. I'll try to find something that's a contradiction inside somebody's argument, and I'll use this form, and then I'll spend most of my paper unpacking why, premise true is, true, and then I can refute my opponent's position or something like that. So we know that without even doing a truth table, we know that this thing is valid just because it has the right form that you would know for chapter 1. But if you had to do it, it's a it's a 2 proposition 4-liner on the truth table. So we just start plugging away. And then my R, and then my P is, and then we are going to solve for this. I know the rest are true. So I know that, that's the case for the first premise, and then take the, take the opposite value for that one. And then for the conclusion, we just simply negate. And then we compare. Sorry. Let me go. How come I didn't? Yep. So now we look for, do we have premises that are both true where the conclusion's false? No, we have only one instance where the premises are both true and the conclusion's true. So therefore, we have a winner, and we know that it's valid. And that's the purpose of that homework, is just find out in conversation, is there an argument? If so, translate it, symbolize it, figure it out, truth table it, valid. And this is fascinating. I mean, it's literally talking about an android. Is it a person? Then it's rational. So this is interesting. So in another class I teach, Intro to Philosophy, we talk about consciousness and what is consciousness. And that would have everything to do with rationality and an android. So it's really fascinating stuff right here going on outside of this argument structure. So yeah, you could know it's valid by 2 ways, just recognizing the form right away from chapter 1 or just plugging out a truth table. So let's do the second one. If we continue to read, we're looking for logical operator words, right? So, but wait, Nick says androids can solve problems and they can. So if we were to play along and say, I don't know, maybe something's going on, there's a conjunction there, and there's a conjunction here, and we have an if, we have a then, we have a so, conclusion indicating word. So let's see if we can map this out. Androids can solve problems and they can deliberate. So let's say solve and deliberate. Say premise 1. And there's a period. So And if they can deliberate or solve problems, then they're rational. Oh, okay. So, and if they can deliberate or solve problems, then they're rational. See how that works? And then I said, right. And then I said, so androids are rational. So whatever we use to translate that, and that just means therefore are. Now, if you were to plug this out, you have an SD and an R. So you have three propositions. How many lines on the truth table? Yep. Now let's see. This will be the last one I work out. And we're done. So let's just try this. If you want to push pause at home and try this and then come back, let's just see if it works. See if you got the right answer. Okay, so I know my R is true, false. By the way, whenever I pause and you're like, what's he doing? I'm pausing because I'm like, where am I? If you do the same thing, it's funny. You're like, wow. Because, when you're doing TFs all over the place, you kind of have to stop and collect your thoughts. Like, okay, where am I? Which one am I on? I don't want to mess this up kind of thing. So I find it hilarious. So when I pause, just know that I'm thinking that. We're just keeping it real, right? Keeping it human. All right, so and notice the pun there because we're talking about androids, whether they're rational, whether they're human. So let's do this. What's our main operator for that premise? For this premise, and then this one's just, itself the proposition. So we'll start plugging away. Both sides have to be true for the whole thing to be true. And so that one's done. And on this second one, so at least one side has to be true. And then I got to solve for this horseshoe over here. So I go with my routine. I look for a true antecedent and a false conclusion, and then I know the whole thing's false. And then just like always, I know everything else is true. And so we'll go. And then we simply know that this one's already done because it's just the proposition itself. So we got 8 lines. Oops, let's do this. Oh, that's interesting. And we want to know, do we have an instance where we have 2 true premises and a false conclusion? No, we have, so on this one, true, and a true, false. So anytime you have a false, you don't have to go all the way across because we're just looking, do we have true premises and a false conclusion? And we don't. So therefore, we have a winner. And this whole thing is valid. And yay, we're done. We're done. Because that was a lot today, right? It's a lot on the human mind. Speaking of androids and rationality. All right. So thanks for hanging in there. We've done 4-liners, 8-liners, 16-liner, not the whole thing, but I showed you how to start doing it. And once again, the most important thing with the 16-liner is 8 truths, 8 falses, 4 truths, 4 falses, 4 truths, 4 false, and so on and so forth. So you can look at this. And that's pretty much it. You should be equipped to, be able to do any and all homework in this section outside of, reading Hurley on your own and getting the added details. But that's it. Thanks for hanging in there. And if you have any questions, just let me know.